Hello friends, I actually have a great news for all of you guys. I just want to give you a quick update that I got a job at Microsoft and I will be starting next week. I'm going to make a whole separate video on the whole interview process and how I get the job. It's a really crazy story, so I hope you like it. And now let's get back to this video. So we got a job at FAANG, but we are not going to stop making LeetCode videos because it's pretty fun for me. So today we are going to do median of two sorted arrays LeetCode problem. And if you see some of the popular companies who have asked this question, there are companies like Amazon, Apple, Goldman Sachs, Microsoft, Google, Bloomberg, Uber, Facebook, LinkedIn, and ByteDance. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So despite being a hard problem, this is a very well-liked problem on LeetCode. Basically, we are given two sorted arrays, nums1 and nums2, and we are told that they could be of different size. So the size can be respectively m and n, that is given over here. Now we need to return the median of these two sorted arrays. We are also told that the overall runtime complexity should be big O of log of m plus n. The solution I'm going to show you today is actually going to do even better than this big O of log of m plus n. I'm actually going to solve this problem in big O of log of minimum value of either m or n. So before we understand this problem any further, first let's see that what does a median mean. So a median is basically any single position inside any given array where everything on the left hand side and everything on the right hand side is actually of same length. So whatever the amount of element it has on the left side, the same amount of elements it has on the right side. Now there could be two cases. There could be like odd numbers or there could be even numbers, and for each one of them I'm going to show you how to calculate the median. So suppose if we take this first example, in this first example we can clearly see that we are given three elements, and based on the definition of a median, everything on the left and everything on the right has to be same. So if we consider this element number 5 is the position where the left of 5 is there is one element and the right of 5 is also there is one element. So in this case 5 is going to be the median for this given array. Now if we take a look at this one, in this example things are a little bit tricky because this is an even number. So in the even case, we actually have two elements in the middle who form the middle portion such that their left portion and right portion becomes of equal size. So in this case, for this particular middle portion, the left value has one element and the right value also has one element. So both of these are part of the median. But the thing is, in the median there cannot be two values. So if such case arises, which is for even numbers, we are actually going to do the average of them. So in this case we are going to do 3 plus 4 divided by 2, which is 7 divided by 2. So we get the answer as 3.5, which is the median for this particular array. If we take this example, again this is simple. This value number 5, again this falls in the middle, so because of that we are going to note 5 as the answer, because there are two elements on the right and two elements on the left. Now again for this case we have the value this 4 and 6 that creates the middle point such that the left values and right values becomes of the same length. So in this case the median is going to be 4 plus 6 divided by 2. So again we get 10 divided by 2. So the answer is 5. And this is the median for this kind of case. Now after understanding what a median is, first let's see these two examples so it makes things more easy. So in the first example, we are given two arrays nums1 and nums2. We can clearly see that they both are sorted array. Like this one only has one element, but still it's sorted, right? And now we need to find the median of these two arrays. So if we find the median of these two arrays, if we combine these two arrays, we will get an array that looks like this, that is sorted, right? Because we need to find the median of two sorted arrays. So this is the combined array. In this case, 2 is going to be the median because that is the middle point where there is one element on the right and one element on the left. Same way for this one, if we try to see, the length of this is actually 2 plus 2, so the total length is 4. Now if we make a combined array, the combined array looks like this, and in this case if we want to find the median of this one, we will actually have to do an average of these two middle portions. So we will do like 2 plus 3 divided by 2, so we get the answer as 2.5, and this is what we need to return as the answer. So let's see that what are going to be the different approaches to find the median of two sorted arrays. The first solution that comes to our mind is a brute force solution. In the brute force solution, the idea is actually simple. If we just combine these two arrays and create like a combined sorted array, we get an array that looks like this. Now, once we have this combined array, all we have to do is just find the median. So in this case, the median is going to be this value number 5 Because on the left hand of the 5 there are going to be exactly 5 elements, and on the right hand of the 5 there are also going to be exactly 5 elements, and this 5 is the answer we need to return. So this solution would give us the correct answer, this brute force solution. But the issue with this solution is that in order to create this combined sorted array, we will actually have to complete this solution in big O of m plus n time. So that is a linear solution, and the thing is that is not what we want. We actually want a logarithmic solution. So let's see that what is going to be the approach for the logarithmic solution. Okay, so before we come up with the optimal solution, first let's try to understand some really important concept. Suppose we are given two arrays that are x and y. We are told that they both are sorted in ascending orders. Now we know that their length is actually respectively 5 and 6 in this case. So the total number of elements we have is actually 11 if we do like 5 plus 6. Okay, so now here we are trying to find the median of two sorted arrays. And the thing is, the median, how we are going to find is that, okay, currently we are given these 11 values. So these 11 values, they are combined of these two. Now this 11, we can actually create two partitions. How we are going to create two partitions? So the logic we are going to use is that every single time, whatever the combined sum is, we are actually going to do like plus 1 divided by 2. So in this case, the value we will get is 11 plus 1. So that is 12 divided by 2. So 12 divided by 2, the value we are going to get is 6. So now first partition we will have to do is of 6 elements. And second partition we will have to do is remaining elements. So remaining elements in this case is 11 minus 6. So that this is going to be 5 elements, right? And whichever is going to be the maximum element of this 6. So maximum element of these 6 is going to place somewhere over here in the middle. And that is going to be our median. Now the thing is, how can we define that this maximum value is going to be the median? What are the properties we are going to take for this 6 and 5 value per partition that we are trying to create? And the answer lies right in front of our eyes, that the sorted property has to be maintained. So what does the sorted property has to be maintained means? It means that all of these 6 values that we are trying to create on the partition, they all has to be less than or equal to the values of the 5 on the right hand side. Okay, so that is a very important property for us to understand. I am telling this again, that all those 6 values that we have on the left hand side, they have to be less than or equal to all the values on the right hand side. Why? Because we are trying to find the median of two sorted arrays. If they are not sorted, then it's like a big mess for us, right? So because this is the sorted property is maintained, now what we are going to do is, we don't care about finding these 5 values. All we are going to put our focus is to finding these 6 values. Now these 6 values, they can exist anywhere inside this x and y. It could be possible that we take like 3 values from x and then we take 3 values from y, and that is how we create the 6 values. It could also be possible that we take like 2 values from x and 4 values from y, and that is also how we create these 6 values. No matter whatever the logic we are going to use, we will always have to be certain that all the elements on the left hand side, they have to be less than or equal to all the elements that are on the right hand side. And using this property, we are going to come up with some very interesting results. So the idea we are going to use is that, first of all, we are going to take whatever the lesser value we have in terms of length among both arrays. So currently in this case, the lesser value of length we have is of array x. So currently for this x, the length we have is 5, right? So what we are going to do is, we are actually going to do 5 plus 2. So 5 plus 2, we get value of 2.5. If we take the ceiling value, we get the value to be 2, which means that now we are going to take 2 values from this x. So if we take 2 values from this x, we will get the values x0 and x1, that is on the left side of the portion. Now if we take 2 values from the x, which means total we are trying to find like 6 values, because remember, we are trying to find like the 2 partitions. One partition is 6, second partition is 5, and all the 6 values has to be less than or equal to these 5 values. So because we are trying to find the partition of 6 values, which means we took 2 values from the x, so we are going to take 4 values from y. Now if we create a partition like this, what is going to happen? Well, all the remaining elements, they are going to be on the right side of the partition. So currently the remaining elements we have. So now we have our 2 partitions, right? Now for these partitions, again, we will have to make sure that this property is maintained. So how can we check that? Okay, over here we are 100% certain that this x1 is always going to be less than or equal to whatever the value of this x2 is. Why? Because we are told that this x array is already sorted. Same is true for this y array, that this y3 is always going to be less than or equal to this y4. This property is always going to be there. So there are no issues with that. But where the issue comes? The issue comes to the place where we don't know that whether this x1, if that is less than or equal to this y4. Same way we don't know that whether this y3, if that is less than or equal to this x2. So in either case, we are going to do the following. First, we are going to take the smaller value. Then we are going to find that what is the partition we are trying to make depending on the starting and ending value. So currently the starting value over here is 0 and the ending value is 4. Okay, so we will, if we do that, we get the value of 2. Now we are going to take two values from here. If we take two values from here, then we will have to check that what are the remaining partition for y and how many values we are going to take from y. So currently from y we are going to take 4 values. Now for all of these values we are going to check that whether this x1 is smaller than this y4, and same way whether this y3 is smaller than this x2. Once the moment we find both of them to be matching, great. If we don't find anyone to be matching, suppose we find out that this x1 is actually greater than this y4. If that is the case, then what needs to be done? Well, the idea is simple. Because this is a greater value and this is a smaller value, which means that this x1 has to go on the right side and this y4 has to come on the left side. Now you will ask that why both of them has to happen simultaneously. Well, if both of them does not happen, how are we going to maintain the number of elements that are needed? Because currently the number of elements that are needed are 6 on this side and 5 on this side. So we have to make sure that we maintain that property. So how can we do that? We can do that by shifting this ending point to come on this side. And rather than keeping like both of these values, we might only keep one value over here and we will try to keep 4 values from here. And same way, if we find that this y3 is greater than x2, again we are going to repeat the same process by shifting the starting point on the right side and repeating the same process. So let me quickly explain the whole process with some examples, and then it is going to make things a lot easier to understand. Okay, so now suppose this is the example of x and y values we are given. I have calculated the total number of elements we have, which is 11 in this case, which means, as explained previously, the left partition that we will have to make, that is combined of x and y elements, that has to be of size 6. Now for this x partition, what we are going to do is, depending on the starting and ending value divided by 2, we are going to calculate that how many elements are needed in the x position, and based on that we would calculate that how many elements are needed in the y, from the y side or from the y side of array, based on this formula of like 6 minus whatever the value we achieve from this x position, and then we will try to compare the values. So first of all, okay, currently this value is 0, this value is 4. If we do like 0 plus 4 divided by 2, we get value as 2. So now, which means that inside this x portion, we are going to take 2 elements, which means for this y portion, we will have to take 4 elements from this y. So now, because this is the left portion, we are going to take the leftmost 2 elements inside the left array, which is 0 and 3 in this case. And from this y portion, we will have to take 4 elements, which means we are going to take the first 4 elements over here. Once done that, basically now we have our left partition setup. So now because we have our left partition setup, we can automatically create our right partition from the remaining values, which are, now we know for sure that this 3 is always going to be less than this 5 because they both belong to x array, and same is true for these two. The thing is, now we are going to do the cross comparison. So currently this 3 is less than 13, which is great that we don't have to worry about anything. The thing is, for this 12 is actually not less than this 5. 12 is actually greater than 5, which means that because we have some element inside this y array which is greater, we will have to move this one on this side and we will have to move this value on the left hand side. So now what we are going to do is, because we will have to add more values from the x, we are actually going to shift our starting point. So where we are going to shift our starting point, the idea is that previously we had the values of s plus e equal to 0 plus 4 divided by 2, like, okay, this value. So we had the middle point as 4 divided by 2 is equal to 2. So now, because this is a binary search, we are actually going to do like 2 plus 1 for the starting point. So now our new starting point comes at position number 3. Okay, so now this is the new starting point, this is the new ending point. Now again we are going to use the same logic. So now for this X partition, a few things have changed. So currently our starting position is 3, ending position is 4 divided by 2, which is 7 by 2. So we get the value 3.5, but we use the ceiling value. So now from this X portion, we will have to take 3 elements. So if from the X portion, we will have to take 3 elements, which means even from the Y portion, we will have to take 3 elements. So let's do that. So this is how the two partitions are going to fall now this time. Now again we compare. Okay, so this 5 is less than 12, so which is good. Now this 8 is still greater than 6. So again we will have to move one element from this to the right hand side. So again we are going to update the value inside our X pointer to move the S element to the next side. So how we are going to do it? Okay, currently this value is 3, this value is 4. So now again we are going to repeat the same process. So we get the value, okay, 3 plus 4 divided by 2. So we get the value of 7 divided by 2, which is 3. Okay, so now we get the value to be 3 plus 1. So this is going to be the new start point. So currently our start and end point, they both fall on the same position. So this is the start point, this is the end point. Now again for this X partition, let's see that how many elements we are going to need. So we will have value 4 plus 4 divided by 2. So 4 plus 4 divided by 2 is going to be 8 divided by 2. So the value is going to be 4, which means we are going to need 4 values from the X partition. So from the Y partition, we are going to need 2 elements. So let's do the math, and now let's create the new partitions. Okay, so these are the two partitions we have. Now let's compare. Okay, so 6 is less than 8, great. 2 is less than 11, great. So now we have created two partitions such that on the left hand side we have 6 elements, on the right hand side we have 5 elements. We were able to calculate that using the total elements we had. The sum we used was total plus 1 divided by 2. So 11 plus 1 divided by 2. So we get 6 elements on the left hand side. Now from these 6 elements, because the total length was odd, so because of this was odd, so what we are going to do is from this left portion, we are going to select the maximum value. Now you would say that, hey, do we need to calculate all the values on the left portion to calculate the maximum value? And the answer is no. Why? Because all we have to do is check these two values. Whichever is greater value is going to be the maximum value on the left portion, because all of these values are sorted. So amongst first 4 values, this is the maximum value, and same way amongst these two values, this is the maximum value. So if we compare the maximum value between these two, basically we will get our desired answer, and in this case the answer is going to be 6. And because this was the odd case, this 6 is going to be the median that we are looking for, and this is going to be the correct answer. Now let's take one more example with odd case and see that how things work out over here. Suppose this is the second example we are given. I did some math. So total number of elements we have is 12, which means that if we want to calculate that how many elements we need in the left portion, basically we are going to do like 12 plus 1 divided by 2. So in this case, we get the answer to be 6.5, but we choose the ceiling value, we choose the floor value, which is going to be 6. Now for this X portion, we are going to do like starting plus ending divided by 2. So first, currently the starting and ending positions are this one. So we get the value to be now, which means we are going to take 2 elements from the X portion. So if we are going to take 2 elements from the X portion, we are going to take 4 elements from the Y portion. So let's do that. These are the two partitions that we have created. Again, let's compare the values. So first, 8 is less than 6. No, that is not true. 8 is actually greater than 6. The moment we find 8 is greater than 6, we will have to move this 8 on the right hand side, and we will have to move this 6 on the left hand side. So let's do that process. So in this case, now what we are going to do is we are actually going to update our end value to come on this side. So again, previously what was the end value? The previous end value was position 4. Now the new end value we are going to create is we are going to find the middle value. So the middle value currently is 0 plus 4, depending. I'm talking about these like starting and ending values. So 0 plus 4 divided by 2. So this is the middle value is 2. So for this ending value, we are actually going to do 2 minus 1. So now let's update our ending position. So our ending position is now going to come at this position number 1. Okay. Now again, we have the updated value of starting and ending values. So now let's try to calculate this X portion and Y portion again. So for now, this time this X portion is actually going to be 0 plus 1 divided by 2, which is going to be like 0.5. But again, we are choosing the floor value. So we will get the value to be 0, which means we are going to take 0 values from this X portion. So if we are taking 0 values from this x portion, which means that we will have to take 6 elements from this y portion, which is okay, cool, no, nothing wrong with that. Okay, so now we have these two values. Now let's do our partition. So now we have created our two portions. Now in this case, because from this x portion we are not going to take any values, we currently have 0 values, right? Now the thing is, previously we have been comparing like this. The thing is, currently in the x portion we actually have 0 elements. So if we have 0 elements, how we are supposed to compare with this one? The idea we are going to use is that every single time we are going to compare the, we are going to consider that this like first value is actually negative infinity and this last value is actually positive infinity. So the minimum and maximum value possible on each one of side. So in any case we come up to this edge case where we need to find, we don't have any values on one portion, we don't get stuck. So we will try to consider this to be negative infinity value. Now negative infinity value is always going to be less than whatever value we have. So it's always like going to be less than 15, which is great. Now we compare these two values. So 7 is actually greater than 0. So because 7 is greater than 0, now what we will have to do is we will have to move our 7 to go on the right side, and we will have to try to bring one element from this x portion. So let's do that. So now we are again going to update the values of our starting and ending values. Now this time we will have to update the start value to go on the right side. So currently the starting position is 0, the ending position is 1. Okay, so the new start value, we will have to find the middle value. So middle value is going to be 0 plus 1 divided by 2, which is going to be 0. We have already established we are trying to taking the ceiling value. So the new starting value is going to be 1. So let's update that, and now we will try to recalculate the whole thing. Now this the number of x element is going to be 1 plus 1 divided by 2. It is going to be 1. So we are going to take one value from this x position, which means we are going to take 5 values from the y position. So let's compare x and y positions. So now we have our two partition setup. So if we compare the 0 with 7, the 0 is less than or equal to 7. That is correct. If we compare the 6 with 8, 6 is also less than or equal to 8, which means that this is a correct partition amongst left and right values. Now in this case, the combination value is actually even for left and right case. So because this is even value, what we are going to do is we are going to pick the maximum value from this one. So maximum value from this one is going to be 6. And we are going to pick the minimum value from this portion. So minimum value from this portion is going to be 7. Now again, same logic, we are only going to compare these two values to find the maximum value. So in this case, we will get that value to be 6. In order to find the minimum values, we are going to only compare these two values, and in this case, the value we are going to get is 7. So now we are going to do the average of these two. So we will get the value of 6 plus 7 divided by 2, which is 13 by 2. So 6.5, that is the answer, and that is the median we need to return. And that is the whole logic behind using this technique. Every single iteration, we are updating the values of starting and ending point only in the array that has the smaller length. So in this case, both the times x had the smaller length. So we are only working on that, and depending on that, we are generating our answer, and we are able to find successfully the median value. So if we calculate the time complexity in this case, the time complexity is actually going to be big O of log of minimum of m or n, and in this case, whatever the minimum value is, we would be able to find the median easily. See space complexity, in this case the space complexity is also going to be big O of one constant space. Why? Because in order to store like the portion, we don't have to store this whole things. We are only concerned with 4 elements, like the minimum of x, the minimum of y, maximum of x, and maximum of y. And using these 4 elements, we can do all sorts of magical things. So this is a very good time and space complexity, and this is a very tough question in my opinion. So if you are able to crack this in an interview, all the companies would be like more than happy to have you as the candidate. So first of all, we are going to compare the lengths of nums1 and nums2. The idea is that whichever has the smaller length, we are going to keep it first. So if not, we are just going to call it recursively again with different inputs. Now we are going to initialize two variables called x and y, and we are going to assign the length of respective numbers. Remember, x is the smaller length and y is the greater length. We are also going to assign two variables called start and end. So start position is going to have the value 0, and end position is going to have the value of whatever the value of x is. Now we are going to run our while loop, that while start is less than end. Now first we are going to calculate that what should be the x portion. So we are going to name it as x part. Once we calculate the x portion, it's easy to calculate the y portion. Okay, now we are going to calculate four important characters. Those four characters are left value of x, right value of x, left value of y, and right value of y. Now each one of them, we are, for every single left portion, we are going to see that if that subsequent like x part or y part, if that value is 0, we will have to put like minus infinity or plus infinity for those values. If not, we will put whatever the subsequent value we can find from this nums array. So let me calculate those four values. Now we have our four values that we are going to need. Now we are going to compare that if the x left and y left, if they are both less than y right and x right, if that is the case, which means we can simply return we have found the correct portion, and depending on whether the total number of values are odd or even, we can simply return the answer. And if that is not the case, we will have to update our start and end variables. So first let's calculate for the correct case. Now we will have to calculate that whether the sum of these nums1 and nums2, if they are odd or even. So if they are odd value, we will simply pick like the maximum value that we have on the left portion, and if it is like the even value, we will pick the maximum value from the left portion and minimum value from the right portion, average of both of them. And if that is not the case, which means the value is odd, so in that case we can simply return the maximum value. If that is not the case, we will have to check that which one end we will have to update. So first we will see that if the given x left, if that is greater than y right, which means we will have to update our end value to come before mid, or else we will have to update our start value. It's basically it. We should get our answer this way. If we don't get our answer, we can simply return 0 outside the loop, so we don't get a compilation error. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions. And I will be posting this solution in the comments, so you can check it out from there. Thank you.